This lesson is on combining functions symbolically, which is what we really want to understand, and graphically, which is what we learn to help us understand why we're doing what we're doing symbolically. And speaking of symbols, here's a bunch of symbols. Adding and subtracting. If you're given two functions, f and g, then you can add those two functions together. Symbolically it would look like that. This just means you're adding f and g, the input is x. It's equal to finding f of x and g of x and adding them together. So this means that difference of f and g is to find f minus g of x is equal to f of x minus g of x. The domain of the sum and difference of a function that you create is the intersection of the domain of each. So if you find the domain of f and then you find the domain of g, the domain of the sum and the difference has to take both of those into account. It's the intersection. So if you've got the restriction in this one, then it's going to be a restriction of the whole thing. So I'll explain. Alright, so the first thing we're going to look at, example 1, we have two different representations of the function. First function f is given symbolically. It's equal to 2x plus 3, which happens to be a line. And the second function g is just 1, 2, 3, 4, 5 specific ordered pairs. So the domain of f plus g and f minus g. Well, the domain of f, that's a line. So there's no restrictions on x, it's not in the denominator, and there is no radical. So, and you know it's a line, so the domain is negative infinity to infinity. The domain of g, however, is very specific. It's explicitly stated. It's only the x coordinates negative 2, 0, 1, 3, and 5. And that's it. So the domain of the sum and difference function would be the intersection between these two, or just the restrictions, and one of them is going to be a restriction to the whole thing. So if this is domain of everything, all the numbers in the world, but this is only these 5 specific numbers, then the domain of f plus g and the domain of f minus g is also going to be restricted down to just these 5 numbers. Okay, so how do you compute f plus g and f minus g? Well, first of all, the domain is very explicit, so we know we're only going to have these x coordinates. Okay, f of x is symbolically defined, so the way you find the outputs with these x coordinates is you plug the x coordinates in for x, and your output is your y coordinates. So we will do that. So f of negative 2 is equal to 2 times negative 2 plus 3, so that's negative 1. F of 0 is equal to 3. F of 1 is equal to 5. F of 3, 2 times 3 is 6 plus 3 is 9. F of 5, 2 times 5 is 10 plus 3 is 13. Okay, so let's make sure that's right. Okay, so now g of x, we've got the table of outputs. So when x is negative 2, g of x is 0. When x is 0, g of x is 3, so forth and so on. Alright, so to find the sum of f and g of x, well, we already know these are our inputs, so all we have to do is just add the y coordinates. This is f of x, this is g of x. So negative 1 plus 0 is negative 1, 3 plus 3 is 6, 5 plus 4 is 9, 9 plus 5 is 14, 13 plus 16 is 19. To find f minus g of x, that's the same as f of x minus g of x, so we'll subtract the y coordinates. Negative 1 minus 0 is negative 1. 3 minus 3 is 0. 5 minus 4 is 1. 9 minus 5 is 4. 13 minus 6 is 7. Okay, so the next one, a little bit more what you would have. You're given two functions. F of x equals x squared plus 1, and it might help you to think, oh, that's a parabola, that's a quadratic. And g of x is a radical function. And notice that x is under a radical. This is an even index. There's going to be restrictions. This is what a radical function looks like. So what happens when you add a quadratic function and a radical function? All right, well, we want to find the domain. So the domain of f, there's no restrictions on x. Is x under a radical? No. Is x in a denominator? No. So you can put any number in the universe in for x. If you know it looks like this, also it shows you that x is anything, negative infinity to infinity. The domain of g, however, we have a restriction. You have to always carry that knowledge about the domain restrictions with you everywhere you go in this class. So this domain, remember, if you have a radical with an even index, you set what's under the radical and you have it memorized. This has to be greater than or equal to 0. So if you add 2 to both sides, you get that this domain is from 2 to infinity. So there's a restriction on this domain. And so the intersection, that just means if it's a restriction here, then it's going to be a restriction in the domain of f plus g or f minus g. So all real numbers domain, but then here it's just from 2 to infinity. So the new function you create is just going to have a domain from bracket 2 to infinity. Okay, so now let's compute that. So f plus g, it just simply means to add those two functions together. Okay, so f of x plus g of x simply means add x squared plus 1 and the square root of x minus 2. And what you've done is you've created a new function. Okay, so this new function, sometimes people don't want to stop here. They think they have to solve for x. What you're doing is creating a new function. So what I thought I'd do is graph this new function. I'll call it, I don't know, k of x. And it is x squared plus 1, and that looks like a parabola like we thought, plus the square root sqrt of x minus 2. And when you look at that, that's not something that I would have guessed it would look like. It gets a little harder to kind of guess what these functions are going to look like, but this seems to have a curve here, and then it starts to look a little bit more curved up. But look at the domain. The domain is from bracket 2 to infinity. So that's what we thought. So you're done. This is it. This is your new function, and it has this domain. If we want to find f of x minus g of x, that would just be f of x minus g of x. And resist the urge. Understand what you're doing. You're creating two new functions that are weird. And that's it. There's no like terms to add or subtract. So that's it. Okay, so example 2, let the dashed red line represent f. So this is not color, so this is f of x, the dashed line, and then the solid line is g of x. Write the domain of f plus g using interval notation. Well, the domain for this one's pretty straightforward because this is a straight line and that's a straight line. They're x's are going to go on forever and ever, so the domain is just all real numbers. All right, and now we want to actually graph f plus g. So we're going to expand this. Here we were given explicit x coordinates. Here we're just given some lines. So what we want to do is just pick some x coordinates, and I only have room for 3 here, so we'll just pick a positive, an x coordinate, a 0, and maybe a negative, a 0, and a positive x coordinate. So maybe I'll pick -2 and 0 and 4. Just randomly pick those x coordinates. Alright, now I've been known to make errors here, so just try to concentrate on one function at a time. So let's just look at the f. When x is -2, f is, it seems to be 1.5, we'll say. And when x is 0, f is 1. And when x is 4, f is 0. Alright, now try to just focus on this solid line. When x is -2, g is -2. And when x is 0, g is -1. And when x is 4, g is 1. Okay, and we want to find f plus g of x. That's the same as f of x plus g of x symbolically. So we're just going to add our y coordinates. 1.5 minus 2 is -0.5. 1 plus -1 is 0, and 0 plus 1 is 1. So now what we want to do is graph the ordered pairs. Here's your x coordinates, and here's your y coordinates that you're going to graph. So -2, -0.5 would be about right here. 0, 0 would be right here. And 4, 1 would be right here. And then you can just connect the dots, because these 3 ordered pairs just represent the 3 points that you're using to graph. And I knew it was going to be a line, because when you add a line and another line, this is where symbolically it might be helpful to see. So like if you have a line, let's say this looks, I don't know what it is, let's call it h of x, so we don't think x plus 4, and then k of x is like, let's make it -x plus 4, 2x plus 3. We haven't learned about degrees, but if you notice that if you add these together, -x plus x is x, and then 4 plus 3 is 7. So you get another line because you don't have a different degree. It's the same degree. So your result is going to be the same type of graph. You can memorize the sum of 2 lines is a line. And then you might want to notice this. This is a negative slope because it's decreasing, and this is a positive slope because it's increasing from left to right. Notice that this is a little steeper than this one, so that's why your result is still an increasing line, but the slope is less steep. Okay, so if we want to do the same thing for f minus g, same thing. I'm going to it's the same line, so I'm going to steal these points. -2, 0, 4, 1.510, and -2, -1, 1. Alright, so f minus g means f of x minus g of x. We know the domain is all real numbers. And now we're going to subtract, so we have to worry about this minus. So 1.5 minus a -2 is the same thing as 1.5 plus 2, so that's 3.5. 1 minus a -1 is 2, and 0 minus 1 is -1. So we'll graph these ordered pairs here. -2, 3.5, 0, 2, and 4, -1. And the difference of 2 lines is going to be another line. Okay, so what happens when you have a quadratic? So that's an x squared and a line. Okay, so these have two different degrees. They're different types of functions. All right, well, you can do the same thing. Again, we want to let the little dashed line be f of x and the solid line be g of x, and we want to pick, you can pick more than 3 points if you want. I'm just going to pick 3, and I'm just going to pick a negative, a 0, and a positive. So I'll pick negative 2, 0, and 2. And I'm going to try to concentrate just on f of x so I don't get confused. And so when x is negative 2, that looks like 5. And when x is 0, that's 1. And when x is 2, also 5. Okay, so if we then look at g of x, when x is negative 2, y is negative 2. And when x is 0, y is 0. And when x is 2, y is 2. Okay, so if we want to find f plus g of x, that's the same thing as adding f of x plus g of x. So f of negative 2 is 5 plus a negative 2. 5 plus negative 2 is 3. 1 plus 0 is 1. 5 plus 2 is 7. So these are my ordered pairs. All right, let's graph that. So we have negative 2, 3, 0, 1, and 2, 7. Okay, so this is obviously not a line. Well, what is it? Well, kind of have to do the symbolic. So I think I know exactly what these graphs equations are. So this is y equals x squared plus 1. I mean, f of x equals x squared plus 1. And this one is our friend y equals x, or g of x equals x. So if we add these together, you can't add x squared plus x. They're not like terms. So you just have to collect all of these unlike terms, and I'll put it in descending order. So f plus g of x is x squared plus x plus 1. And because it's an x squared, that is a quadratic. So that tells me that this result is going to be some sort of parabola. Now, I'm not real sure where the vertex is. That's beyond where we are right now, so I'm not worried about that. But the result of a quadratic and a line is going to take on the degree, x squared degree. So we have that. Didn't do the domain because this is a pretty trivial domain. This is all real numbers. That's all real numbers. So the domain of f plus g and f minus g is negative infinity to infinity. All right, if we want to graph f minus g, same graph, so I'll go ahead and just copy this down. All right, but this time we're doing f of x minus g of x, so we have to pay attention to this minus. So 5 minus a negative 2 is actually 7. 1 minus 0 is 1, and 5 minus 2 is 3. So we have negative 2, 7. 0, 1, and 2, 3. And same thing as before. This is a degree 2. It's an x squared, and this is an x. So when you have x squared plus 1 minus x, that's going to leave you with x squared minus x plus 1. So this is what f minus g of x is. This new function, it's going to be a parabola. And so the idea of this graphing is just to really get you to understand that when you add two functions, you're not solving for x. We got to move beyond that. That's pre-algebra. That's algebra. That's all you did. Now we're creating new functions. So f of x plus g of x created this new parabola that got slid over just a little bit. F of x minus g of x created this new parabola that got slid over just a little bit. That's what it looks symbolically. x squared plus 1, this function, minus that function created that function. So don't go and try to solve for x. Alright, what happens when you have two parabolas? What's going to happen? Well, if you know the degree here is 2, the degree here is 2, you know, what is going to happen? We'll see. Okay, so we're counting by ones, so I'm just going to pick, only have room for 3. These tables are for your convenience. You may not have those on the test, so you just pick as many ordered pairs as you need. I'm going to pick -1, 0, and 1 as my x coordinates. If you need to pick more, you can. Then I'm going to, let's see, let's let this one here be, the dashed one here be f of x, and the solid one be g of x. Okay, so f of x, when x is -1, we have 0. And when x is 0, we have -1. And when x is 1, we have 0. And g of x, which is this one, when x is -1, we have 3. And when x is 0, we have 4. And when x is 1, we have 3. Okay, we know the domain of this goes on forever and ever, and that goes on forever. There are no restrictions on the x-coordinates. On x-axis, x can be anything. So the domain of f minus g is going to be -infinity to infinity. All right, now let's find f minus g. So we will take these y coordinates because f minus g of x is the same thing as f of x minus g of x. So 0 minus 3 is -3. -1 minus 4 is -5. 0 minus 3 is -3. And we have these points. So we'll graph -1, -3, 0, -5, and 1, -3. Okay, so it does not look like it is a line. It looks like the result is a quadratic. And if I had to guess what these, I can tell what these are. So f of x was positive x squared minus 1, and this is negative x squared plus 4. Okay, so if I subtract these two, you've got to be very careful. F of x minus g of x, let's use parentheses, is x squared minus 1 minus parentheses negative x squared plus 4. So if I distribute the negative, I get a positive x squared and a negative 4. And I end up with 1x squared plus 1x squared is 2x squared, and then minus 5. So there it is, there's a parabola. Now if I were to add these two, I may not get a parabola, because if I were to add these two, just look, I'm not going to do it. What happens to this? X squared plus a negative x squared goes 0. -1 plus 4 is 3. So actually if I were to add these two, I would get just a horizontal line right through y equals 3. So that's interesting. We're just creating new functions. And the other idea is that the domain of f and the domain of g, the intersection of those domains is the domain of f plus g or f minus g. Okay, so the next thing is what happens if you multiply. Okay, so if you multiply, the product f times g is defined, you just take the two functions and multiply them together, and the domain is the same thing. The domain of f times g is the intersection between the domain of f and the domain of g. So you just find the domain of each one, and if it's a restriction in one, it's going to be a restriction in the final. Okay, so you got a little bit more going on when you have multiplication. So let's see, let's let this dashed line be f of x and this solid line be g of x. And the first thing we want to do is write the domain. Okay, so we'll do that. pretty easy domain, hopefully. This has domain all real numbers, that has domain all real numbers. There are no restrictions on the x coordinates, so the domain of f times g is negative infinity, infinity. Okay, because we're multiplying, that means that the quote-unquote degree, which you haven't learned yet, this is x to the 1 power, and a linear is x to the 1 power. When you multiply an x times an x, you know that's x squared. So when you start multiplying, the degree is going to change. And when the degree changes, the shape of the graph will change. Okay, so it's a little more complicated when you multiply. That's really all you need to know. So that's why we have a couple extra steps. So the first thing you want to do is you want to locate the zeros of the product. And the way you do that is you find the zeros of each function. So remember, zeros means x-intercepts. So the x-intercept for this f of x function is 4. And when x is 4, f is 0. Okay, the x-intercept for g, it's intersecting that x-axis at 2. And so when x is 2, g is 0. Alright, let's figure out when x is 4, what's g? G is 1. When x is 2, what is f? F is, we'll say 0.5. And then if we multiply these zeros together, these y coordinates, 0 times 1 is 0, 0.5 times 0 is 0. So what do we learn there? We learn that the zeros of f and g are the zeros of the product. Okay, so we know that the result is going to go through 4 and 2. Now why is that important? Well, the easiest way to graph these is to create these intervals. It says a sign chart can help organize when the graph is above or below the x-axis. Remember, positive numbers are above the x-axis and negative numbers are below. Okay, so what I'm doing is I took these zeros. There's a 0 at 2 and 4, and so I broke this x-axis into 3 pieces. Okay, this interval is negative infinity to 2. This interval is 2 to 4, and this interval is 4 to infinity. Alright, and now all I have to do is make a sign chart, which means I don't care about the actual numbers, I just care about the sign. So just concentrate on the f function, and in this region, see how this f of x is above the x-axis? That means all the y values are positive. And in this region, see how this f function is still above the x-axis? Okay, and then look at the f function here in this interval. See how they're below the x-axis, so that's a negative. Okay, let's look at g. Negative infinity to 2, g is below the x-axis. But 2 to 4, g is above, so that's a plus. And from 4 to infinity, it's also above, so that's a plus. Now, we're multiplying, right? So just multiply using your sign rules. What is a positive times a negative? It's a negative. What's a positive times a positive? It's a positive. What's a negative times a positive? It's a negative. So what that means is that this new function that we're creating, from negative infinity to 2, it's a negative. That means it's going to be below the x-axis. From 2 to 4, it's positive. That means it's going to be above the x-axis. And from 4 to infinity, it's a negative, so that means it's going to be below the x-axis. Okay, so if we graph, all we have to do is just sort of sketch that out. The zeros, this is where it's going to hit the x-axis, so we're going to start out below, but make sure we hit this here, and then between 2 and 4, it's above, and then from 4 to infinity, it's below. And look what it turns out to be. It turns out to be a parabola. That means it's x squared. Here's the reason why. I don't want to figure out what these functions are, so I'm going to use different. So let's say I have the first one is negative x plus 2, and the second one is positive x minus 3. What's going to happen if you multiply those two together? So if we multiply k times h together, that's this. And we know how to multiply those together. You FOIL, that's going to be negative x squared plus 5x minus 6. I did that quickly in my head just because the main point is, look what happens when you multiply x to the negative x to the first power times a positive x to the first power. You're going to get a negative x to the second power. Okay, so with a product, when you're multiplying the degrees, that means that they're going to change. So you started out with two lines, you ended up with a parabola because you end up with an x squared. So to make it easier on us, you don't need to know any of this. It's just I'm trying to link it. When it's a product, you want to find the zeros and you want to make a sign chart, and then you want to use the negative, positive, negative to figure out what the graph is going to look like. Okay, so let's try this one. We have two lines, and we're going to let F be the dashed line and G be the solid line. And so again, we're trying to find the product, F times G. The domain is going to be all real numbers because lines don't have any restrictions on their domain. And the zeros are, looks like negative 1 and 3. And you can fill this out, but I know that those are going to be the zeros of the function. Okay, so then remember what we do here. We make a sign chart, and we're going to split this into 3 intervals. Okay, so this interval is negative infinity to negative 1. This interval here is negative 1 to 3. This interval here is 3 to infinity. And F is below the x-axis from negative infinity to negative 1. It's above the x-axis after that. G is below the x-axis from negative infinity to negative 1. It's also below the x-axis from negative 1 to 3, but it's above the x-axis there. Then you're finding the product. So a negative times a negative is a positive. Positive times a negative is a negative. Positive times a positive is a positive. So we're talking this graph is going to be above the x-axis, below the x-axis, above the x-axis. We know that these are the zeros of this product, so we know what's got to go through there. So we're going to be above, below, and then come back and be above, and there it is. Alright, same thing. This time though we have a parabola and a line, and we need to find its product. Again, the domain, there's no restrictions on a parabola. It goes on, x's are going to go on forever to the left, forever to the right. Same thing with a line. So that's your domain. We got to find the zeros since we're dealing with a product, and the f function does not cross the x-axis anywhere, and this line crosses the x-axis at 0. So that's the only 0 I can see. Alright, so this means that you're only going to have negative infinity to 0 and then 0 to infinity. And f is above the x-axis all the time. And g is below the x-axis to the left of 0 and above the x-axis to the right of 0. So then a positive times a negative is a negative, and a positive times a positive is a positive. So this means it's below the x-axis. This means it's above the x-axis. So we'll start out below. We know this is a 0, okay? And this is going to be a strange one. I happen to know it's going to look like that. Now, how would I know that? Well, it's because really our objective is to understand the symbolic goings on. So just for your curiosity, what's happening is f of x happens to be a quadratic. X squared plus 1 is the y-intercept. G of x is a line. It's our friend y equals x. Now what's going to happen when we multiply those together? So f times g of x, this is the main thing that you need to understand, how to do this. How to multiply two functions symbolically. Well, you just use your algebra rules and you're going to distribute that x and you're going to end up with x cubed plus x. That is your new function. And I happen to know what that looks like. That is a cubic function, and a cubic function has this little bend in it, like that. Okay, so the idea is for you to understand using these graphic methods that really when you're adding, subtracting, or multiplying two functions together, you're creating a new function. All right, so we'll keep going. I'm going to skip this one. I'll maybe show the answer at the end, but it's 37 minutes in, so I do want to get to the U-try part where we're just not dealing with the graph anymore, and we're just symbolically creating new functions. And these domains are a little harder. So I'm going to pause and try them, and then come back with me. Okay, so f of x is a radical function. Did you notice that it's going to have a domain restriction? G of x is a rational function. It also is going to have a domain restriction. So finding the domain of f plus g, f minus g, and f times g is the same. You want to find the domain of this one, and then it's the intersection. So the domain of f, remember how you do it? You take what's under the radical and memorize that what's under a radical, if it's even index, has to be greater than or equal to 0. So if I subtract 3, I get negative x is greater than or equal to negative 3. And then don't forget, I like to put a negative 1. When you divide by a negative number, you're going to switch that inequality. So the domain of f is that x has to be less than or equal to 3. All right, the domain of g, a little more complicated. It's a rational function, and we know that the denominator cannot equal 0. And so hopefully you remember that a quadratic, to solve a quadratic, you have to factor it. Now this, I didn't go over in the factoring video, but this is actually an easier one to factor. You don't need trial and error because it's called a difference of two squares. It's just going to factor into x plus 5, x minus 5. Now you can do it with trial and error, but you know that. And then 25 is 1 and 25, or 5 and 5. And I've told you to do the ones that are close together. So if you've got a perfect square here, it's just going to be the same binomial except one's a plus and one's a minus. Anyway, then you set each of these not equal to 0. And x cannot equal 5. So we're going to have quite a complicated domain here for these three, because remember, all of these things have to be true. Okay, so I'm going to try to help you understand by just doing one number line. I'm going to put the key numbers in order, so negative 5 and then 3 and then 5. Okay, always start with the not equal to's because they just show up as wholes. So I'm going to put a hole here and a hole here. So I've taken care of that. Now what is x is less than or equal to 3? That has to be true. All the numbers have to be less than or equal to 3. So that would mean you would have a colored in circle at 3 and to the left, but remember it can't be negative 5. And this is the reason why you have to graph, because it turns out this isn't needed. 5 isn't needed, can't be 5 isn't needed because we know it has to be less than or equal to 3. So our domain of f plus g and f minus g and f times g, because it's always the intersection, is start left to right, parentheses, negative infinity to negative 5, parentheses, union, negative 5 to 3, bracket. Okay, now computing f plus g with an input x simply means add up the two functions. So f of x is the square root of 3 minus x, and g of x is 1 over x squared minus 25. And we're not in this class ready to add those up. Now if you do an online source, it might simplify that, and I will be able to tell you used an online source, so don't do that. Just leave it that way. That's it. We're not solving for x. We're creating a weird, wacky function where if I were to graph that, it would look strange. All right. F minus g would be the same thing, except a minus in the front, in the middle. Square root of 3 minus x minus 1 over x squared minus 25. C, f times g of x would be this function. Square root of 3 minus x times 1 over x squared minus 25. Now I am going to do a little simplifying here because you should know this. How do you multiply these two together? Well, you can make anything a fraction. So the square root of 3 minus x is simply the square root of 3 minus x over 1. And multiplying fractions is easy. When I say easy, I always think of things like easy, medium, hard. Not easy as in you should do it, be able to do it. Multiplying fractions, you don't have to get a common denominator. All you have to do is multiply straight across. So square root of 3 minus x times 1 is square root of 3 minus x. And 1 times x squared minus 25 is x squared minus 25. So that's worth simplifying. You end up with a rational function with a radical on the top. And you can see that this means that all the numbers have to be less than or equal to 3, but they can't be 5, but they can't be negative 5. So that domain checks out. Okay, and number 9, I went ahead and did it for you. What I did was I just went right across the x-axis and wrote down the zeros. And I didn't really bother with that because if it's a 0 in either one of these, it's a 0 in the product. So that's all I did. And I used those values to create these intervals. Left to right, from negative infinity to negative 2, negative 2 to negative 1, negative 1 to 1, 1 to 2, and 2 to infinity. So those red lines kind of help you see the intervals. And then I looked at the dashed function and found out it's above, above, below, above, above. And then I looked at the g function and found out it was below, and then above, 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 and then below. And then I'm doing the product, so I used my sign rules and got negative, positive, negative, positive, negative. Now again, I'm not perfect, but I fixed it this time. I made a mistake here and had below, below, below. And I kind of had an idea that it should be alternating. Not always, but I knew what to look for, and so I was like, that doesn't look right to me. Let me double check. And sure enough, I had made a mistake, and I fixed it, and it ended up being below, above, below, above, below. So then I was ready to draw my function. I started below, went to that 0, then went above, went to that 0, went below, to that 0, went above, and then below. And I had an idea that that was what I was going to get, because I have, just to do the symbolic stuff, I have a function f that's an x squared function, and a function g that is an x squared function. And when I multiply, x squared times x squared is an x to the 4th function. Now this happens to be a negative x to the 4th, but I know the way an x to the 4th function can behave is it can look like that. So that's how I knew that.